Hey guys, welcome to day 12. First off, really excellent work the last 2 days in class. Working with the chain rule, you guys are picking it up really quick. It's a tricky rule, but it always follows the same pattern as long as you're careful and know the pattern really well and know the rule really well, you'll do great. Today I want to talk about what if we have a composition of more than two functions, okay? And we're also going to talk a little bit about hybrid rules. So let's start with this. Let's say we have a function within a function within a function. Oops. Just did our basic one. Okay. Let's say I have a function h of x within a function g of x within a function f of x. Okay. So I'll just call this k of x equals. How now would we find k prime of x? Well, what we have here is it's like a chain rule within a chain rule. Okay, I call it sometimes chainception. So we have to start with the chain rule, which says the derivative of the outside with respect to the inside times the derivative of the inside. And that outside we're talking about is the outermost function. In this case, it would be f. Okay? But what's going to happen here is we're going to have to end up doing the chain rule twice. Okay, so when we see these types of problems, they show up from time to time on the AP exam, so we want to be ready for them. Here's how we do it. We start with the derivative of the outside, right? I'm going to call this right now the inside and this the outside. Okay? And I'm going to do the derivative of the outside with respect to the inside. He's going to need one more parenthesis. So that's the derivative of the outside with respect to the inside. But the chain rule then says I have to multiply by the derivative of the inside. Well, my inside has an inside and outside. So when I look here, I have an inside and an outside here. So when I go to do the derivative of the inside, when I want to do the derivative of g of h of x, I have to apply the chain rule here as well. So the derivative of the inside is really, right? There's multiple insides going on here. I'm talking about this inside here. The derivative of g of h of x we know is g prime of h of x times h prime of x. So we end up with a pretty long function here, but we end up with f prime of g of h of x times g prime of h of x times h prime of x. Okay, and we could add 4, 5, 6 functions. They don't show up on the AP exam very often, or ever, that I've seen. But we could keep applying this chain rule and just work our way from outside in and do the derivative of the outside with respect to the inside times the derivative of the inside. Okay, so really it's like doing the chain rule twice. And what I like to call it is two chains. So I like to call this two chains because I have to do the chain rule twice. Let me show you an example of what this can look like. We might see a function like this. So if we see something like this, the function f of x is sine cubed of 4x squared. What we have here is a composition of 3 different functions. 4x squared is a function within sine of x, which is a function within x cubed. Again, it's going to be helpful to think of this function, right? To think of this exponent here as we are cubing the entire sine of 4x squared. So again, it's going to be helpful to think of it like this. So we want to be able to apply that. You guys are doing a great job of applying that in class. There's various places we've seen it. So if I want to do f prime of x now, I'm going to start with the derivative of the outermost function, right? Here's my out. And again, I can think of this whole thing as the in. Or I can think of it as an outside, a middle, and an inside. The innermost function here is 4x squared. The outermost function here is x cubed. The one that's in between is sine of x. So I'm just going to work my way from outside in. I'm going to do the derivative of the outside. So I'm going to start with 3 and keep the inside the same. Sine of 4x squared squared. That's the derivative of the outside with respect to the inside. But now I got to come back and derive sine of 4x squared. Well, when I derive sine of 4x squared, I have to again apply the chain rule. I have an inside here and an outside here. I do the derivative of the outer function with respect to the inner function times the derivative of that inner function. Okay. I'm not done until I put that times 8x at the very end. Now, we might clean this up because on the multiple choice, they're not going to write it all spaced out like that and unsimplified like that. I can combine this 3 and this 8x to make 24x. I'm just going to write this with the nice notation of sine squared 4x squared cos 4x squared. And there's my final answer. Nice and simplified. Let me show you another example we might see. This could involve like a table or something. I just want to show you, we know how to use the table, we know how to use the graphs. Let's say they gave us some function p of x, and they said it's equal to g to the 4th of 2x. Again, I have a function 2x within a function g within a function x to the 4th. So what do I got to do? I got to 2 chains this thing. Again, I'm going to rewrite p of x as g of 2x, that whole quantity raised to the 4th power. Outside, middle, inside. So p prime of x then would be the derivative of the outside with respect to the inside times the derivative of the inside, which is another chain rule. Derivative of outside with respect to inside times derivative of inside. Very last one is the one that people tend to forget or leave off by accident. Again, cleaning this thing up, p prime of x then would look something like this. I can combine my 4 and my 2 here to make 8. I'll use that nice notation that the problem was written in. There's my final answer. Okay. So that's 2 chains. Again, it seems really confusing at first, but as long as you keep things straight, you can work your way to that correct answer. Okay. Let's talk a little bit about hybrid rules. This is not a new rule. Right? If a car runs on hybrid power, it means a combination of gas and electric. Hybrid rules are when we have a chain rule and a product rule, or a chain rule and a quotient rule, or a product rule and a quotient rule. Okay, so sometimes we execute multiple rules at the same time. So these are easiest to see through examples. So take a look at this example. So here I see f of x is equal to e to the 4x cubed times sine of negative 2x. But when you look at this and I say, what rule do you use? Well, there are multiple rules going on. So I see a function times another function. So that tells me, right, that's multiplication in here. That tells me I'm going to have to use a product rule here. But that first function is a composition of two functions, 4x cubed and e to the x. That second function is also a composition of two functions, negative 2x and sine x. So here's what I'm going to do. I'm going to do the product rule, but when I do the derivative of the first or the derivative of the second, if I have a composition, I have to do the chain rule when I get to that. Okay, so here's how this is going to look. So I'm going to follow the framework of the product rule. The product rule, again, is the derivative of the first times the second plus the first times the derivative of the second. But I'm just reminding myself ahead of time that when I do the derivative of the first or when I do the derivative of the second, there's chain rule implications here, so I'm going to have to apply the chain rule. Okay, so here's what this will look like. I'm going to start with the derivative of the first. Derivative of e to the 4x cubed, I know is e to the 4x cubed times 12x squared. That is the derivative of the first. What a lot of people do is then they go to that derivative of the second. That's not the product rule. The product rule says we do the derivative of the first. So this is the derivative of the first right here. And it included this chain rule. So derivative of the first, now I have to multiply by the second. Not the derivative of the second, but the second. So I have to then multiply by sine of negative 2x. Okay? Derivative of the first, including chain rule, times the second, plus the first, e to the 4x cubed, times the derivative of the second. Now when I do the derivative of the second, that's going to involve a chain rule because I see that negative 2x composed with inside of x. So when I go to do the derivative of the second, I'm going to do the derivative of the outside with respect to the inside times the derivative of the inside. So I did the product rule, but the two different times that I had to do a derivative, I ended up having to use the chain rule. Now sometimes only one of those will be a composition, so you only have to do the chain rule once and just a regular derivative the other time. Okay, but be ready for whatever the situation calls for. Okay. So cleaning this thing up, it might look something like this. I'm going to call this 12x squared e to the 4x cubed sine of negative 2x. Now instead of writing a plus here, I see that this times negative 2 is going to make my whole term negative, so I'm just going to call this minus. I'm going to put that 2 up front, 2e to the 4x cubed cosine of negative 2x. Now again, we don't see these hybrid rules all the time, but I have seen them, and I'll show you some examples from years past. We'll see. So here we have this derivative right here. It's easy to get lost, and it's easy for your brain to hurt when you're doing these. Okay, but really keep things straight. You know your rules, you know your product rule, and you know your chain rule. Make sure that you apply them correctly. Let's take a look at a second example. So let's say g of x equals tangent of x squared over 3x to the fourth. Now when we look at this, and if the question is to find g prime of x, just by looking at this thing, we should recognize that this is a quotient rule problem. But this tangent of x squared up here, when we are going to do the derivative of this top part, to do that derivative, I have to use the chain rule here. Okay. This 3x to the fourth is just a simple power rule. So this, the example 1 had two different compositions that were multiplied together. Here I have one composition divided by just your standard 3x to the fourth. Okay, but again, I got to keep things straight, and I got to make sure I apply these rules correctly. So to find g prime of x, feel free to pause the video and try it on your own and see what you get. To find g prime of x here, I'm going to start with the derivative of the top. Hey, that's where my chain rule is. The derivative of the top will be the derivative of the outside with respect to the inside times the derivative of the inside. That's the derivative of the top. But then I need to multiply the derivative of the top by the bottom. So that gets tacked in there as well. Again, I have the derivative of the top, including the chain rule, times the bottom, minus the top, times the derivative of the bottom. The derivative of 3x to the fourth would be 12x cubed. All divided by the bottom function squared. Again, I only had to use the chain rule once in here because only my numerator was a composition of functions. My denominator wasn't. So the derivative of the bottom wasn't too bad. The derivative of the top, I had to remember to apply the chain rule and get that 2x in here. Okay? Again, practicing simplifying this down. Again, don't do anything with that x squared because it's part of secant squared. Okay, but I can combine my 2x and my 3x to the fourth. I'm going to put those out front and call this thing, what is that, 6x to the fifth secant squared of x squared minus, I'm just going to write the polynomial in front, 12x cubed tangent of x squared, all divided by, I know 3 squared is 9, x to the fourth squared is x to the eighth. And there is a more simplified, but not totally simplified version of this. Okay, looking at these numbers, I see 6, 9, and 12. Those numbers are all divisible by 3. I also see at least an x cubed in every term. Again, I'm not going to do any simplification with this x squared or this x squared. But x cubed, x to the eighth, x to the fifth, I can take out an x cubed. 6, 9, and 12, I can factor out a 3. So, what is that all going to look like? Well, again, I'm dividing my coefficients all by 3. 6 divided by 3 is 2. I'm taking 3 powers of x's away. So that x to the fifth is going to end up being x squared. Twelve divided by 3 is 4. All the x cubes are gone. Divided by 9 divided by 3 is 3. X to the eighth divided by x cubed will be x to the fifth. And there's my nice simplified final answer. Okay. So that is it for today. We'll practice this more on Thursday and get ready to review for our next test. I'll talk to you guys later. 2 chains. Bye.